Welcome to an introduction to moving straight ahead. We will be filling out this worksheet as we go over this screencast together, and I will show you a PowerPoint. So moving straight ahead is this next unit that we're doing, and it is a continuation of a unit that you started in 6th grade called Variables and Patterns, where you looked at a bicycle tour and you did some problems that were related to that. Maybe the two people riding their bicycle kind of jogs your memory. If you can remember about the different college students that were creating a bike tour and some of the problems that were related to it. So in that unit, you had used contextual situations. That just means word problems. You also used tables, graphs, and equations to represent patterns relating variables such as cost, income, and profit. So you had two variables and you saw how they were related to one another, and you were looking for a constant rate of change, and we will be continuing with that with this unit. So you can read this right here, this little paragraph, and notice that, I don't know if you remember this graph from your last year in 6th grade, but Adrian's bike shop fees, you notice that in this graph there are two variables. There are the number of bikes, which is on the x-axis, and the rental fee, which is on the y-axis. And as the number of bikes increase, so you look in this graph, they're increasing, and the number of bikes in this graph are going up by 5, so every other one is 5. So as the number of bikes increase by 5, the rental fee also increases. And we know that there is if you look at the points, we see that they line up, and I'm trying to draw a straight line, but it's not very straight, is it? I'm sorry. But they line up and make a straight line. And one of the things that we say in variables and patterns is, if the line is straight, there's a constant rate. So since the line is straight here, that means that there's a constant rate between the cost and the number of bikes. And I can see right here that 600 bikes, this is 600 here, cost $20. So if 600 bikes cost $20, and if 1,200 bikes cost $40, then that would mean how much would it be per bike? Well, 600. So as the number of bikes go up by 20, the price goes up by 600. So that's $600 more for 20 more bikes. That's $30 a bike. So the constant rate of change in this graph, this is me writing, oh, it's bad. The constant rate of change is $30 per bike. That $30 per bike is also called the unit rate. So the constant rate of change and the unit rate are the same per bike. So as you can see, this is it's also, not only is it a continuation of variables and patterns, it's also a continuation of what we just did in comparing and scaling. We had some graphs and unit rates too. Now, when you have a straight line, a relationship between two variables which all points lie on a straight line is called a linear relationship. Don't let the word or the phrase linear relationship confuse you. I know it seems linear is a very strange word, but if you look at the word linear and you look at the first 4 letters in the word linear, you see the word line. So linear just means that it makes a line. So on your paper, it asks you to draw an example of what is linear and what is not. So you can pause the video now and create your own example of those two things. Here are the examples that I have. This one is linear because it makes a straight line. It's not proportional because it doesn't go through the origin, but it is linear. Whereas this picture here, which kind of looks more like the line I just made earlier, is not linear because it's got the zigzag, jaggedy quality to it. These last questions, you don't have to answer them, but I would like you to read them. By the end of the first investigation, we should be able to answer all these questions. Well, thank you for watching the video. Hopefully you have your paper filled in and you have a good foundation of what it means to say a relationship is linear. Remember, linear relationships are just relationships that create a straight line on a graph. Thanks.